Hello everyone, my name is Komasinyolo. Welcome to another video by Attention Matrix, where we try to make learning fun and easy. Please comment, like, and subscribe if you would like us to continue making this content and you enjoy it or find it helpful. Now on to the next video. Let's get right into it. Okay, so in this video we are going to continue with functions. We're going to continue with the parabola, and we are going to be looking at the second standard form of our parabola. Okay, so in previous videos we looked at the first standard form, which was ax squared plus bx plus c. In this video we're going to be looking at this standard form, a open bracket x minus p close bracket all squared plus q. Okay, I'm going to be describing what each of those parameters in this equation means. So p, q, a, and x and y, we already know what they mean. Okay, so I'm going to be explaining this equation. I'm going to be explaining why it's important, or its advantage over the other standard form that we started off with, and we will do one or two simple examples to get the concept through, to understand this standard form better. Okay, so for the standard form, we've got A, we've got P and Q. Now, this standard form here, this P here and that Q here are very important. The P and the Q there indicate what we call the turning point. Okay, they show us what we call the turning point of our function, of our parabola. So we've got the turning point. You can abbreviate it as TP, so the turning point. Now, I'm gonna come back and explain this in more detail. I just want to explain it graphically first. I just want to explain what the turning point is. Now, what is a turning point? Okay, so if you've got a Cartesian plane there, you got a Cartesian plane, and you've got a graph on your Cartesian plane, and it's a parabolic graph, it's a quadratic graph, then your graph will look like either that. It could look like that, it could look like that, right? It could look many different ways. Now, when you look at this graph, there is a single point at which the graph turns. Okay, there is a single point at which the graph turns, hence the turning point. Now, if you look at this graph, it turns at that point there. If you look at this graph, it turns at that point there. Now, those points have coordinates. They have an x coordinate and they have a y coordinate, right? The turning point has an x coordinate and they have a y coordinate. Okay, they're made up of coordinates because they are points. They are turning points. So that's what the turning point is. Okay, so basically how we express these coordinates, we usually say T, P for turning point, and then we open our bracket, write in our x there, and then our y there. Okay, so that's our turning point. So the turning point of a parabolic graph or quadratic graph is basically the point at which your graph turns. Okay, it turns. If I want to be more technical, I could say the gradient of the graph changes from positive to negative, or from negative to positive at the turning point, right after the turning point. But I want to explain that when we are looking at differential calculus. I don't think it's necessary for me to explain it here. So we'll look at it at a later stage. Okay, so that's what a turning point is. Okay, so the turning point, that's what the turning point means. So the standard form here, actually, its advantage over the first standard form is that we can immediately get our turning point from this standard form. Okay, so what is A? A is a constant. A is just a constant. It's a constant. Okay, it's just a coefficient of that entire thing. Okay, so that's A, and then P is our x value. Actually, let me write that. Let me try to write this a bit neater on a. Let me just write it neater so that it's easy to follow, easy to understand. Okay, so if we've got this. We've got our standard form of y is equal to a open bracket x minus p all all squared plus q. Okay, now what I said is the standard form helps us to identify the turning point of the quadratic function that we will be looking at. That whatever quadratic function we're looking at that is expressed in this form, we can immediately tell what the turning point is. So this value p here, p, which is that value there, p is the x value of our turning point. Okay, p is the x value of our turning point. Now, whatever sign you have here, so you see you have a negative here, right? If you have a negative here, it means that the x value of the turning point is the opposite of that sign, so it's positive. Okay, so if you have a negative there, then the x value is going to be positive. Okay, if you have a positive turning point of your x value, then that value is negative. If you have a negative x value, then that negative from the x value is going to multiply this negative, and then it's going to be positive. Okay, so just remember, it's important to remember that whatever that you take the actual value of p here, right? The actual value of p as your turning point. Okay, just the value of p. You can ignore the sign. Basically, you can ignore the sign. You can ignore the negative sign in this instance. Okay, and then if this sign is positive here, then you know that the value for your turning point for your x is going to be negative. Okay, so you basically don't ignore the sign, take the opposite of the sign. Whatever the sign is there, take the opposite and use it as your sign for your turning point. Okay, so, and then this q, you probably can guess what it is. The q represents the y value of your turning point. Okay, so the y value of your turning point. So this is the advantage of writing your quadratic equation in this form. You can immediately tell what your turning point is. Okay, instead of having to calculate it. And by the way, I should explain to you how to calculate the turning point. I will do that in either this video or one of the subsequent videos. Okay, that I'm going to make. So okay, so that's basically what those mean. So a is just a coefficient, p is your x value of your turning point, q is your y value of your turning point. Now, remember the standard form that we started off with. We had this standard form, y is equal to a x squared plus b x plus c. We can actually transform this standard this standard form into this standard form. Okay, into this standard form that we were just looking at right now. We can actually transform it into that form, and then I will show you during the course of this video how to do that. But firstly, before we get to that, let's just do a couple of examples, a couple of quick examples of how you would go about dealing with this type of form, this quadratic form. Let's say you've got y is equal to, open bracket, x minus 2 all squared plus 4. Okay, you can immediately see that the turning point of this graph, based on my explanation, the coordinates of the turning point are, remember, it's that value, that's your x value, so it's going to be 2. Because the sign is negative here, you use a positive. Okay, because the sign is negative, this is going to be positive 2, and this is going to be 4. Right, here you keep the sign. Okay, you keep the sign, so that's going to be positive 4. And then this is the value of your turning point. And what does it mean? What does this mean? This graph will have a turning point at I just want to see when y is equal to 0, x is equal. Yeah, it's gonna have your x intercepts somewhere. I haven't calculated the x intercepts. One of them is gonna be, yeah, I don't know exactly where the graph is gonna be, but your turning point simply means that whatever the coordinate is, so this is positive, right? So then the turning point of this graph, this is your x value is 2, so your 2 is gonna be here. Then your y value is 4. 1, 2, 3, 4. Your y value is 4, your x value is 2. So your turning point is going to be where the 2 and the 4 meet. Okay, where the 2 and the 4 meet, this is that point there. This is where your graph is going to turn. So your graph is going to look the way it looks, and it's going to turn at that point. That's where your turning point is. Okay, let's do another example. Another quick example just to illustrate this thing. So if you've got y is equal to let's say minus x minus 4 squared plus 5. Okay, so your turning point would be what? By inspection, you can see that your turning point, so this is a negative, so you know that your x value is going to be positive 4. Then your y value is going to be positive 5, right? And then if you were to sort of indicatively give the position of this graph and to sketch what it looks like, you will notice that that value there is negative. That's your a, so your value is negative. So your graph, we know that if a is less than 0, then your graph is sad. Okay, we covered that in previous videos. So that's the shape of your graph. It's going to be a frown. It's going to be sad. So, and then we know that your turning point is going to be at x is equal to 4 and y is equal to 5. So 1, 2, 3, 4, and 1, 2, 3, 4, 5. So 5 is there and 4 is there. Then where those 2 points meet, that's where your turning point is going to be, and your graph is going to do that. It's going to do that. Okay, when you sketch it roughly, it's going to do that, and it's going to have a y-intercept somewhere there. Okay, so that's roughly, that's what your graph is going to look like, and that's where your turning point is going to be. Okay, so you can see that based on just these two pieces of information, the sign of A and the turning point, the coordinates of the turning point, we can sort of get a very good idea of what our graph looks like. Okay, so that's basically how you interpret this graph. Now, I did say to you earlier on that you can convert the first standard form to this standard form, right, that we're currently looking at in this video. So let's use a standard form that you are familiar with. Say you've got x squared plus 6x. I like this function. It's my go-to when I use examples. And then plus 8. Right, say you want to express this as a standard form, right, as a standard form for this video that we're covering in this video. Well, what you would have to do is the following. Actually, let me use my colors here intentionally so that I can do something. You've got y is equal to x squared. Now what you're going to do when you're converting this to the standard form is that you're going to say, okay, you're going to write this, right? You've got 6x, and then you're going to say plus 8, right? You're going to keep the original equation as you have it, but if you want to convert it to the standard form that we're looking at in this video, what you do is you look at the middle number, or the number that is with the letter x. That's with the variable x. So you look at that number there, you take that number, you put it in brackets, right? You put it in brackets, you divide it by 2, and then you square it. Okay? What are you going to get when you take this number divided by 2 and square it? Well, 6 divided by 2 is 3, so this is going to be 3 squared. This is going to give you 9, right? Once you have that number, then you add it to your original equation and you subtract it. Now, why do you do that? You don't want to change your original equation. So what is 9 minus 9? 9 minus 9 is essentially 0. 9 minus 9 is 0. So we basically haven't done anything to this equation because this is x squared, this is x squared, this is 6x, this is 8, and this is 0, right? So we might as well, we just added 0 to this thing. So we haven't really changed anything from this equation. We just amended it a little just so we can manipulate it. So, right, remember how I got to these 9s. I said I looked at the middle number, I divided it by 2 here at the bottom, and then I squared the answer, then I got to my 9, right? So that's what I did. So I'm just gonna remove the steps that I followed here so that I can write the 9s on their own. Okay, so right, I said plus 9 minus 9, right? And then from here, what do I do? Well, from here, I'm just going to say, okay, here's what I want to do. I want to take the 9 that I added and I want to interchange it with the 8. So I want to bring the 8 to this side and then the 9 that side. I'm just going to change the position of the two, right? The positions of the two, so that I have the following. I have y is equal to x squared plus 6x, and then that 9, I'm just going to take it and put it here, plus 9, right? And then that 8 that I had, I'm just rearranging now. I'm just changing the order of things. Okay, and then I'm going to keep the other 9 minus 9 here. I just changed the order. This equation is still exactly the same equation as that, right? Because I still have plus 9 minus 9, which is 0. 9 minus 9 is 0. So the stuff in black still stays, and then the stuff in red gives me 0 when I add it up. Okay, so I still haven't changed the value of the equation. Materially, I haven't changed that. The equations are identical. They just look different, but they behave identically. Okay, so now what I'm going to do is I'm going to take this and I'm going to factorize it. Okay, I'm going to take that and I'm going to factorize it. What do I get when I factorize that? Well, when I factorize this, what I get is, remember how to factorize? If you don't remember how to factorize, just revisit your past content from your previous grades, and then just remember how to factorize. Now this is going to be x plus 3. When I factorize this is going to be x plus 3 and x plus 3. Okay, I'm factorizing this stuff here. Then what is 8 minus 9? 8 minus 9 is minus 1. Okay, and then I can see these two factors are identical. Since they are identical, I can just square them. So I can just say x plus 3 all squared minus 1. Okay, and then what do you see? What do you notice? What do you notice? You will notice that this is the standard form. This is the standard form of this current video, the main focus of this video. We've officially converted one standard form to the second standard form. We've converted it, and now you can immediately see that the turning point of this equation is minus 3 and minus 1. Okay, the turning point is minus 3 and minus 1, which is the same as that. Because it's the same equation, it's identical, minus 3 and minus 1. That's the turning point of this equation. But you see, you can't tell what the turning point is from this equation, but you can immediately tell what the turning point is from this equation. Okay, so there are advantages. This one, remember, the advantage of this one is that you can immediately tell what the y-intercept is. The y-intercept is 8, but you can't tell that the y-intercept is 8 from looking at this standard form. Okay, so that's the advantage of this equation. Okay, and how, speaking of turning points, how would you calculate a turning point of this standard form, the first standard form? Because from this standard form that you see down here, you can calculate the y-intercept by simply saying x is equal to 0, right? And you can find your y-intercept because you can't get your y-intercept by inspection. But how would you calculate your turning point from this one here? Because you can't tell what your turning point is from inspection. So let's do that. You can't do it by inspection, so let's do that. The turning point of this standard form, so y is equal to ax squared plus bx plus c. Turning point, how do you calculate the turning point? How do you calculate the turning point? Well, it turns out that the x value of the turning point, can be calculated from minus b over 2a. This is the formula for the x value of the turning point. There's also a formula for the y value of the turning point, but I'm not gonna use that. But what I would like you to do instead is to use the x value of the turning point to find the y value of the turning point by substituting it back into the equation. Okay, so let me show you what I mean. Let me just give you an example. Let's say you've got I'm going to use that same example again. Y is equal to x squared plus 6x plus 8. How do you calculate the turning point of this equation? Well, first thing that you do, you could either convert it to the standard form where we have P and Q, or you could say, you know that the turning point of the x value of your turning point is equal to minus b over 2a, right? So the x value of your turning point would be equal to, what is b? Okay, let me color code this. So this is b, right? This is b. We know that this is b from our standard form. We know that a in this case is 1, right? This is a, right? And then we know that this is c. Okay, this should be obvious to you by now. Okay, so minus, let me use black, minus b, where b is 6 divided by 2 times a, where a is 1. Okay, this is going to give you minus 6 divided by 2, and this is going to give you minus 3. Okay, so this is the x value of your turning point. Now, what is the y value of your turning point? Well, the y value of your turning point, you just take your original equation, which is x squared plus 6x plus 8, and you substitute x. Because now you have x, you want the corresponding value of y, right? So what is y? Y, when x is equal to minus 3, so wherever you see x, you substitute minus 3, plus 6 times minus 3 plus 8. Okay, and then you solve. What is minus 3 squared? Minus 3 squared is 9. Okay, what is 6 times minus 3? 6 times minus 3 is minus 18. Then plus 8. Then this is equal to, equal to 9 minus 10. Okay, this is equal to 9 minus 10, and your answer is going to be minus 1. So then the coordinates of your turning point are, your x value is minus 3, your y value is minus 1, right? So your turning point, the coordinates of your turning point, TP, coordinates of your turning point are going to be x is minus 3, y is minus 1. Now you will notice minus 3 and minus 1. That's the answer that you got, right? What was the answer that we got from that form? This form here. Minus 3 and minus 1. There it is there. It's the same answer, right? So that's the method that I just showed you right now, is to calculate the turning point using the formula, using this formula, right? But if you don't want to use this formula, you can just take the original equation, convert it to the turning point standard form, and then use that form to calculate your turning point. Okay, so those are the basics of the second form of your parabola. It's basically P is your x value and Q is your y value. Where did I write it? P is your x value and Q is your y value. This is your y value, this is your x value. Remember the sign, take the opposite of whatever the sign is there, and that is the standard form of your equation. Okay, so that's basically it. Let's just sketch one more time. This standard form. Now what if I give you, let's say y is equal to 2x plus 3 squared minus 11. It's very easy. If you want to sketch this roughly, your turning point is, what is your turning point? Your turning point is minus 3 and minus 11. Okay, so you know 1, 2, 3 is there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 is here. And where these two meet, This is where your turning point is. And what is the sign of your A? A is greater than 0, so your graph is smiling, right? It's smiling, it's not there. I'm just showing you the shape there. It turns at that point. So your graph turns at that point and it's smiling. So it does that very roughly. Okay. And then in order for you to find those points there, you follow the same exact procedure as you did for the procedure in the previous video, where you find your x-intercept, your y-intercept, and then you can sketch, right? Here you have to find your x-intercepts. You have to find your x-intercepts and then sketch. Okay, so let's quickly do that actually. Let's quickly do that for an example. Let's quickly sketch where we follow the entire process. Okay, let's say I want to come up with a simple one. X plus 1 squared plus 1 squared plus 1. Okay, now let's say the question is sketch this graph. Okay, you want to sketch. How would you go about sketching this graph? Well, step number 1, remember, revisit the previous video. Step number 1 is you find your y-intercept. Your y-intercept when x is equal to 0. I explained this in the previous video. Okay, so when x is equal to 0, you get your y-intercept. So all you do is wherever you see x, you substitute y. Wherever you see x, you substitute 0, right? So you've got x there. There's your x there. Instead of x, you're going to write 0. So that's 0 plus 1 squared plus 1. So your y-intercept will be 1 squared plus 1, which will be 1 plus 1, which will be 2. So that's your y-intercept. Okay. What is your x-intercept? Remember, your x-intercept is when y is equal to 0. So wherever you see y, you're going to put in 0. Our equation that we're solving is x plus 1 squared plus 1. So wherever you see y, you're going to put in 0. So there's y there. 0 is equal to x plus 1 squared plus 1. Okay, and then you can simply expand this and solve. Okay, you can expand this and solve. So this is 0 is equal to x plus 1, x plus 1 plus 1. Okay, so then you can simply use the FOIL method to multiply the stuff out. So this is going to be x times x. It's going to be x squared. Then you're going to have x times 1. Then you're going to have plus x. Then you're going to have 1 times x. That's going to be x. Then you're going to have 1 times 1. That's going to be 1. Okay, I'm just expanding. So this is going to be x squared plus 2x plus 1. Okay, and then you can factorize. You can easily factorize this and solve for your x. So this is going to be, I'm not going to explain factorization. I explained it in the previous video. You can look at the previous video and get the concept from there. This is going to be x when you factorize. This is going to be x. This is going to be 1, 1. Then this is going to be plus, plus. And then what you have, this is plus 1 here. Don't forget that plus 1 there. And there's another plus 1 there. I think I made a mistake. Wait. Okay. Actually, before we get to this step, I neglected that one there before. So before we get to this step, let's fix my mistake. So I've got x squared plus x plus 1 plus 1 there. Okay, then x squared plus 2x plus 1 plus 1 plus 1. I neglected that one. So ultimately I'm going to have x squared plus 2x plus 3. Because I have 1 plus 1 plus 1. Okay, so that's 3. And then you're going to factorize this thing. Okay, you're going to factorize it. You're going to have x here. You're going to have x here. Okay, then you're going to have, let's see what you're going to have. 3 times 1 is 3, 3 minus 1. Yeah, you're going to have to use the quadratic formula to get your values of x here. Okay, so you're going to have x here, you're going to have x here, you're going to have some value here, some value there. Use your quadratic formula. Okay, so you're going to have minus b plus that, and then b squared minus 4ac over 2a. Okay, then you're going to get x1 and x2. You're going to get your answers here. So I'm not going to go through the whole process of doing that here. You know how to use the quadratic formula. You get your x values, and then once you get your x values, you've got your x-intercepts, and then you can sketch them. And then you can sketch them. Okay, so you've got your y-intercept, and you've got your x-intercepts, and then you can sketch your graph. Okay, and you know your turning point as well, but that's just additional information. It's a nice to have, the turning point, but you don't really need it to be able to sketch this graph. Okay, so I explained sketching in detail in the previous video. You can just look at that video if you don't follow. The main purpose of this video was to explain the second standard form and what each of those factors mean and how to work with it, what each of those terms, those parameters mean, and how to work with them. Okay, so the intent of this video was fulfilled. Okay, so in the next video I will explain the third standard form, and we will wrap up our parabolic functions. Till next time. Lesson number one, lesson number one. Lesson number one, lesson number one.